one, I know I have an alternating series. I can tell that the terms are positive, so the test is not going to apply if it's not decreasing or if my limit as n goes to infinity of the a to the n does not equal 0. That's the easiest one to test. So I'm going to start by testing that one. If I look at n plus 1 over n, that's equal to 1, which is not 0. So I can't use alternating series test. But it's interesting to keep looking at, and maybe we'll want to apply ratio test, which we're going to see in a few videos later. And we could try that. The other thing I could think about is separating this. So looking at this sum, if I look at the fraction and separate it, I could say that's the same as -1 to the n plus 1. And then this fraction is the same as 1 plus 1 over n. I know I can take my sums and separate them. This is 1 to infinity, -1 to the n plus 1 times 1, plus sum of 1 to infinity, -1 to the n plus 1, 1 over n. So I just saw that this converges by the alternating series test. But what about this? If I think about that, that's just a series of, it'll start with +1, -1, +1, -1, etc. So depending on where my infinity is, it's either going to be 0, because all of these will make 0, all of those pairs, or it's going to be 1, because it might end with a +1. So this sum is either 0 or 1, and it's oscillating back and forth, which means that although the sum might exist, we don't know which of the numbers it is. So it's not that this really diverges, but it's that it does not converge. So overall, this series does not converge. We can't say diverge, but we can say that it does not converge. So not every series is one or the other. There's also this ambiguous scenario. So this series does not converge, is all we can say definitely.